So today we will study the gas power cycles. So that is our next chapter. So we are meeting after a long time due to the coronavirus, but we'll still keep on our study on. And the gas power cycle consists of many things. First of all, before going for the gas power cycle and other things, we will try to learn the preliminary things like heat engine. What exactly a heat engine is? We have already studied in the class many times that a heat engine is a device which converts the chemical energy into the heat energy first of all, and the heat energy is further utilized into the, like, this is your heat engine. It is taking the heat, that is a Q1, from the temperature source. The source is basically petrol or a diesel or any of the form of the chemical energy that is getting converted into the, first of all, the heat energy once it is burnt or the combustible, and after that some amount of it is being liberated into the atmosphere to the sink, which is a waste energy, and some amount is getting converted into the work. So this W will be equal to Q1 minus Q2. We have already studied this point. Now one more question comes into the mind, that is the how many types of the heat engines are already there into the into our environment or whatever we have created, we human being have created. The first one is that the external combustion engine. External combustion engine. External combustion engine. Second one is the internal combustion engine. Internal combustion engines. And third one, first one is the external combustion engines are nowadays are not in use. This is external combustion engines are not in use nowadays. For example, are steam engine, steam locomotive engines, basically locomotive engines, which used to run a train in the previous times, that is not in use nowadays. But as far as the internal combustion engine means, the in which the fuel is burnt internally. You cannot see the fuel burning like this, like in case of your scooter, car, bus, aeroplane, etc. You cannot see the engine and all. Internal engine, what exactly is happening inside. So that is why they are also known as the internal combustion engine, because the fuel which is burning into the engine, that is totally inside. You cannot view it with the naked eye. So that is why internal combustion engine. Again, the internal combustion engine has got into the two types. That is the internal combustion engine. We also call it as a IC engines. Please remember this point. This is again into the two types. This is the spark ignition and is a compression ignition. We have already discussed these points in the class, because I am memorizing you these points because we are meeting after so many days due to the lockdown and the curfew which has been imposed due to the coronavirus and all. Anyway, so due to the, as far as your spark ignition engine is concerned, in this is the engine, internal combustion engine, in which the fuel will be combustible due to spark. Example is your scooter or a petrol car, petrol vehicle. All petrol vehicles are spark ignition. As far as CI is concerned, this is a compression ignition. Compression means you are compressing the air first and you are increasing the temperature of the air, and after that you are injecting the fuel like diesel into the high temperature zone, and it will be automatically catch the fire. So for example, your bus means the diesel bus, diesel operated vehicle, maybe your car also, like Swift Desire and all. So these are all examples of the internal combustion engine. So moreover, one more point I forgot to tell you, that the compression ignition engines are also known as the diesel engine, because their second thing is the compression ratio of the compression ignition engine is much more than that of the spark ignition engine. So now we will try something else. Now we will try to understand what is the air standard efficiency. What do you mean by the air standard efficiency? The mechanical cycle of the petrol and diesel engine can be modeled into thermodynamic processes. So thermal efficiency, first of all we must understand of what is the thermal efficiency. Thermal efficiency means thermal efficiency. So neta is the symbol of the thermal efficiency. Let it be T is in the subscript. So neta thermal. So we can call it as a work done divided by the heat input. Likewise, this is your heat engine. It is getting a Q1 amount of heat from the source, as we have learned earlier. This is W and this is Q2 and this is your sink. So W is the work done, Q1 minus Q2. So neta thermal will be equal to W divided by Q1, means the work done divided by heat added. So W is your Q1, we can also write it as a Q1 minus Q2 divided by Q1. We can also 1 minus Q2 divided by Q1. So this is how this is thermal efficiency. So this is the thermal efficiency. A thermodynamic cycle working on the air with the working as a, so this is a working. If this is the basically the heat engine. Now we are coming to the point, the air standard efficiency. If the cycle of the engine, we know that the engine works on the different cycles, and a cycle contains the processes, maybe 3 processes or 4 processes. Generally it's a 4 processes. So as far as the 4 processes are concerned, if a fuel is being used into that, if the working substance is air, if the working substance is air, then the engine is called, or a cycle is called, then cycle is called air standard cycle. And the efficiency of such an engine and efficiency of air standard cycle is called air standard efficiency. So now in the later part, in the second video, we will learn the piston cylinder arrangements and the different points, what is the piston, what is the cylinder, what is TDC, what is BDC, what is the clearance volume, what is the swaft volume, what is the different abbreviation that has been used, how do we calculate the power of the engine and all, and what is the MEP, mean effective pressure and all. So these are all terms we will learn in the second video, because this video, if we will discuss these points in this video, the video will go beyond the limits and it will be too longer for you to understand. So thank you very much for being with me for this video. Thank you.